David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, quadratic functions review. We're going to go over all the key parts of our most recent chapter in our quadratics unit. Stay tuned for a review of the previous two chapters. Two equation forms for quadratics. Standard form, y equals ax squared plus bx plus c, and vertex form, y equals a times x minus h squared plus k. Each form has advantages over the other one. Let's take a look. Vertex, the all-important point of your parabola. This is where the direction turns. It'll change from decreasing to increasing right at the vertex, or it will change from increasing to decreasing right at the vertex. Understanding that vertex is key to creating a good graph and often key to understanding one of the word problems that ask for a maximum or a minimum. Okay, so remember, this is a minimum, that's a maximum. Okay, let's take a look at how to find the vertex. In standard form, the x-coordinate of the vertex is just minus b over 2a. Whatever that number is, you take it and plug it in for x, and that spits out the y-coordinate. So in that way, y is f of minus b over 2a. This is function notation. Okay, so you want to be practiced up on that. That will give you the vertex. Now, vertex form is great because you can just pull the vertex out by inspection, which means you can just see it and write it down. No calculation necessary. The vertex in vertex form is just hk. You just got to remember to change the sign on the h. So if this shows up here as negative 3, this is 3. So there's your vertex from vertex form. Okay, let's take a look at the x-intercepts. For standard form, we just set the equation equal to 0 and solve for x. So you put 0 in for y, and then you use your techniques from the previous chapter to solve for x. That will give you your x-intercepts. And this works the same in both forms. This one might be easier to solve for x at some point, and this one might be easier, just depends on the equation. Now, as you recall, a parabola can miss the x-axis entirely. If this parabola is completely above the x-axis, there will be no x-intercepts. So when you solve that function, you will find that there are no solutions. So that's the 0 solutions. The second case is the parabola can just dip down and touch the x-axis or rise up and touch it before it goes back down. So there's only one x-intercept. That would be an equation with one solution. And then of course, if the parabola crosses the x-axis and crosses it back, we have two solutions or two x-intercepts. Y-intercepts. This is where you like standard form. The y-intercept is just c. That's where it crosses the y-axis. And that happens when x is equal to 0. So if you plug 0 in for x in this equation, these two terms just go away and it's c. So that's why I wrote 0c. That's your y-intercept, found by setting x equal to 0. Vertex form is just not good for finding the y-intercept. Here's a common mistake. Students will look at this equation and go, oh, the y-intercept is k. And that's not right. I know why we do that, because in standard form, the y-intercept is just this constant that's hanging out there. And this looks the same. It's just a number hanging out there. However, this equation is organized in a completely different way, so your k is not your c. So what you have to do, if you're given a vertex form quadratic equation, is you have to convert it to standard form. You have to multiply this binomial, multiply through by a, and then combine your like terms, and that will give you standard form, and then you can grab c. So what I wrote here is found by converting to standard form, and then it's just 0c like it was in standard form. Lastly, we have the shape. This is what the a term does for us. And the a is the same in both equations here, okay? So it's going to be the same exact value. Doesn't matter which form you're in. And a controls a whole lot about the parabola. If you're rough on that, I have a video called What Does A Do? You want to watch that. If a is positive, If it's a positive number, the parabola opens up like this one. If a is negative, the parabola opens down. Super simple, okay? Now we have the little bit more complicated. A narrower parabola happens when a is bigger than 1 or less than negative 1. So if a is like 5 or 20, the parabola is going to be narrower like that. Or if a is negative 10, it's going to be narrower in the downward way. Likewise, your parabola would be wider if a is between negative 1 and positive 1. So that's like if a is a fraction, like a half or a quarter, or a decimal like 0.5 or 0.67 or something like that. So if a is between negative 1 and positive 1, it's going to be a wider parabola. Now you've heard me talking about wider and narrower. Wider than what? Narrower than what? Remember, in the very beginning of this unit, we talked about the fundamental parabola, y equals x squared. So that's the parent parabola that's related to every parabola on the planet. In fact, there are interesting videos out there that can show you that really there's only one parabola shape. You can blow up or shrink down any parabola so that it looks just like any other parabola. However, if we're not blowing up or shrinking, then parabolas can be narrower than y equals x squared or wider than y equals x squared. Okay, what else do you need to know how to do? Let's go over some points. Completing the square. We just mentioned that. What it does is it converts the quadratic from standard form to vertex form. There's a whole video on how to do that for this chapter, and then also in the Solving Quadratics chapter. So you've got two different videos that treat you how to do that, and there's a slight variation in the process for each one. Second thing, solving quadratics. Okay? So solving quadratics, we do that for a certain reason. Pause the video and see if you can think of what that reason is. Okay, if you said finding the x-intercepts, you are correct. This is where we set y equals to 0 and solve for x. The reason that that finds the x-intercepts is that when the parabola crosses the x-axis, the y value is 0. Okay? We had 3 techniques for doing that. Some of the problems are very easily factorable, so you can do that. We had like 3 or 4 different factoring techniques. You'll want to be up on all of those. We can also complete the square and then solve it. That's another process. You might have a question that asks you to do that. Finally, we have the quadratic formula. This is the big old plug and chug method for finding the x-intercepts. Quadratic formula will solve any quadratic and help you find the intercepts. But remember that I may ask you to solve by factoring or completing the square. So don't just focus on this technique to the exclusion of these 2. Also, this technique can be really long, and sometimes factoring it's really obvious how to factor. So don't lose those skills. Finally, the last 2 days, we've spent time on word problems. And these are complicated situations that are governed by quadratic equations like throwing a ball in the air or a company making profit, things like that. You're given a quadratic equation and you're asked questions like, how high does the ball go? When does it hit the ground? Or at what quantity does a company maximize its profit? So answering all those questions involves finding the vertex and the intercepts. And sometimes it's tricky to understand from the way they write the questions exactly what you're after. So you want to review those. Okay, so now let's talk about sketching quadratic functions. This is where this all comes together. I've got an example function here, fairly straightforward function, and we're going to go ahead and figure out all the important points, and then we'll give it a sketch as well. So we are in standard form. Let's find our intercepts. The y-intercept. This one is super easy. Pause the video, figure out the y-intercept. Okay, let's see how you did. It's just this number with a 0 in front. It's at 0 minus 12. Bam! X-intercept. Set the equation equal to 0 and solve. So 0 equals x squared minus 4x minus 12. So this is a straightforward product sum factor. 2 numbers that multiply to negative 12, that add to negative 4. Those would be x minus 6 times x plus 2. Negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. Solve this out. X minus 6 equals 0, x equals 6. This is the intercept 6, 0. And this one is x plus 2 equals 0. This is the intercept x equals minus 2, which is minus 2, 0. Okay, let's find the vertex. We know that the x-coordinate of the vertex is given by minus b over 2 times a. b is negative 4, so minus b is positive 4 over 2 times 1. That's going to be 4 over 2, which is 2. Now what we do is we take the 2, plug it back into our function, and get y equals 2 squared minus 4 times 2 minus 12. And this is going to give us 4 minus 8 is negative 4, minus 12 is minus 16. So the vertex is 2, negative 16. Now we can graph it. I'm going to do 5, 10, 15, 20. 5, 10, 15, 20. Negative 20. Negative 20. Plot our points. Our y-intercept, 0, negative 12. Right about there. Our x-intercept, the first one is 6, 0. The second one is negative 2, 0. And finally, our vertex is 2, negative 16, which is right about there. Draw my graph. And bam! Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.